Hello, in this video, I'm just going to show a quick demonstration of my RREF calculator, which is just a C program that will take matrices, well, basically systems of linear equations, and reduce them into reduced row echelon form, just so it'll make it easier to solve these problems if needed. So let's go ahead and open it up. I just opened the project, and the first thing it asks you to do is to define how many rows present in the matrix, which can either be in between 2 and 100. So for this example, I'm just going to say it's going to be 3 rows long, which means that the matrix will be just a bunch of 3D vectors. And I'm going to define how many columns are present. So I'm going to say, let's just say 3. Also, just make sure to note that this whole program is assuming that this is an augmented matrix and not a matrix of coefficients. Just keep that in mind. So after we define the columns and rows, the program asks us if we want to change any of the rows or if we want to stop. And in that case, it will go ahead and do all the calculations. So for me, I want to create an inconsistent system. So what I'm going to do is I'm going to press 1 to change a row. I'm going to pick row 1, and I'm just going to type in the values 1, 0, and 1. And then I'm going to go to change row again, and I'm going to change row 2, and I'm going to say it's 1, 0, 0. And so basically, this is just going to give me an inconsistent system. It's basically just because equation 1 is essentially just 2 but shifted. So we are going to press 2 to stop. And as you can see, it says the system is inconsistent. So that's just one of the cases that could happen. So now we're going to go ahead and move on to a system where it is consistent, but there's only one real solution to it. Okay, so I restart the project, and I'm going to this time create a 2x3 matrix. And I'm going to go ahead and set the first row to be 2, 1, and then 2, 4, and then 6. And then the second row, I'll just make it -3. Oh yeah, I didn't define it first. 2, I'm going to pick row 2, and then I'm going to make that -3, 5, and I guess 9. And so if I tell it to solve it, as you can see, it's a consistent system. It gives me the variables, -0.273, and the variable 2, which is 1.636. Just keep in mind these are rounded. They're not 100% accurate, but they're pretty close. And it also tells you how many basic variables you have and how many free variables you have. And that actually segues to the next part of this video, which I'm going to show you what happens when there are free variables and what you can do with this program to define them. Okay, so I reset the program, and this time I'm going to create a 2x4 matrix, which is essentially just 2 3D planes. And so this time I want to make the first row equal 1, 1, 1, and 1. And the second row, I want it to be 2, 3, 5, and 1. And then when I click stop, it's going to give me my variables. But the difference here is that variable 1 and variable 2 both rely on variable 3 to get an answer, or basically get a value. And variable 3 here is a free variable. So essentially what my program does, is it asks me if I want to calculate a specific solution. If I pick yes, it's going to tell me to define variable 3. So I'm just going to say 5. And it gives me that solution. They give me the solution to the equation the linear system of equations, if variable 3 equals 5. And I can continue to do this over and over and over again until I eventually tell the program to stop by clicking 2. And that's the project. So overall, nothing too complex, but this is just a easier, quicker way to solve matrices, just determined to reduce row echelon form. If you're in a rush or in a hurry, or you just want to check your work, this can be useful. and I thought this was pretty cool. So I wanted to showcase this program that I made.